From digital engineering to signaling engineers, traffic controllers, signalers, drivers and maintenance staff. At Europe's Rail, players from different sectors, companies and countries come together to create the single European railway area, a European railway system without borders. The safety system, called European Train Control System, or ERTMS, is radio-based and does not need line-side signaling anymore. One challenge for the experts involved in the planning and construction of new solutions is communicating with each other. For example, a German maintenance expert uses completely different tools, symbols and display methods than a colleague from France who works in the same ERTMS infrastructure. This makes it difficult to exchange information and to work together. This is why we are working on a common data language in the digital railway system, where CCS stands for Control Command and Signaling System, and TMS for Traffic Management System. At the heart of safety is ERTMS, the European Train Control System. With the CCS TMS data model, we do not only facilitate data exchanges in the digital railway system, we also foster the standardization of user interfaces. Based on ERA vocabulary and ontology of the EU Agency for Railways, we create an international standard that makes it easy to share, adapt, and use information among different players, parties, and companies. Let us take a closer look on how we do that. Hello, my name is Boriana and I am working at the DB Infrago. Today, we will discuss the topic of the CCS TMS data model to support standardized user interfaces. In this presentation, we will talk about several topics. First is the development of the CCS TMS data model schema based on the ERA vocabulary. Then, how to generate the track layout CCS TMS files based on the CCS TMS schema. Then we will use these files in an engineering process to get the data configuration files for designing CCS TMS assets. We will also discuss how to integrate kilometric information in CCS TMS, and we will give an introduction about the catalog of symbols. Then we will show how to use CCS TMS files to support specific user interfaces. As said, the CCS TMS data model is based on ERA vocabulary. So our goal here is to develop a schema which represents the CCS TMS data model. To do this, we automatically derive the CCS TMS data model in a JSON notation. From this point, we generate schemas in XSD and JSON schema to validate XML and JSON files. Once we have developed a CCS TMS schema based on ERA vocabulary, our target is to create CCS TMS files, to exchange information between different stakeholders, and to continue processing of this information. To do this, we take project raw data in combination with these schemas. We then follow a manual or scripting approach, or use a programming library which allows serialization and deserialization into CCS TMS files. One use case of CCS TMS files is generating railway assets along the tracks following ETCS Level 2 automatically. For this, we have a CCS TMS file containing empty tracks and then import the information into an engineering tool. The engineering tool shall apply the generic ETCS-only engineering rules from Europe's Rail. After performing the engineering process, we export into the CCS TMS files again to exchange this information with different user groups. The CCS TMS data model also allows storage of kilometric information. Users might be interested in specific assets along the tracks by providing position, geographical location, and kilometer information relevant to these assets. We use specific objects in the CCS TMS data model and store this information in the CCS TMS files. To represent the information inside CCS TMS files, a catalog of symbols has been provided, which includes all necessary asset visualizations. This includes engineering, operations, and information for the driver or maintenance. To make the process easier, the catalog of symbols has been provided in an SVG container where the assets are represented graphically. We use this container to integrate different views into the application according to the respective user group. Using the SVG container in a combination with the CCS TMS files, we can directly go to viewing the information inside the CCS TMS files, or it can be extended by the kilometric information as explained, and continue the viewing phase. We have 3 files: infrastructure, engineering, and map. Infrastructure contains the information about topology and geometry, and necessary information. We have engineering, which has extension information for the infrastructure to hold ETCS Level 2 information, and we have map area, which is a projection of these elements. So, we'll try to load this information into AutoCAD using Rail-Complete. I will select the 3 files: infrastructure, engineering, and map. Rail-Complete will try to visualize all contained information. As we can see, the tracks are totally empty. There are no items along them. What we'll try to do then is to automate the process of placing these assets. We are targeting specifically ETCS marker boards, axle counters, and balize groups. We'll proceed with the code. Items have been successfully loaded. We can see the results on the screen. We have ETCS marker boards, axle counters, and balize groups. It's covering all the tracks. Let us try to export the results of this process. We will export 4 files. We have infrastructure, engineering area, map area, and ADO segment profiles. To visualize the information inside the CCS TMS data model, an example file is provided. We have 2 maps. We have an engineering map for signaling engineers and maintenance staff, and we have an operational map for signalers and traffic controllers. Both maps represent 2 different domains and serve the different user groups. To visualize the information, we need a catalog of symbols, which contains specific asset items for visualizing these domains. We have 3 types of asset items: ETCS marker boards, axle counters, and balize groups. As described, we have used the catalog of symbols and the CCS TMS files to visualize the information. As we can see, we have ETCS marker boards, axle counters, and balize groups. If we want to visualize the kilometric information, this will be done by extending the engineering, where a kilometer sign object will be created and storing the kilometric information by providing a mapping between geographical information and kilometric information. We can activate the kilometric information, and we see that it can acquire it from the data and place correctly. Also, we can change views from engineering to operation. For this, we deactivate the kilometric information and change to operations. As we can see, the visualization has changed according to the user group. Also, the symbols have changed to different representations. This is done with help of the catalog of symbols in the SVG container. The catalog of symbols also offers different items for the driver. As the drivers move along the tracks, they will see different objects according to the operational scenario. For example, change of power supply system or pantograph information. With the CCS TMS data model to standardize user interfaces, we are bringing all players together: signaling engineers, traffic controllers, signalers, maintainers, and drivers. To accomplish that, we are digitizing and standardizing processes across countries for standardized ETCS engineering and operations for a single European railway area.